What if we could transform other planets into habitable worlds like Earth? Imagine a future where humanity spreads across the cosmos, transforming barren landscapes into lush environments teeming with life. This concept, known as terraforming, raises fascinating questions about our ability to reshape worlds beyond our own. As we gaze at the night sky, we cannot help but wonder, can we really turn Mars into a second Earth or create a paradise on Venus? Terraforming is not just a flight of fancy. It is a scientific endeavor that combines biology, engineering, and planetary science. The idea of altering an entire planet's environment to support human life has captured the imagination of scientists and dreamers alike. But how feasible is it? What would it take to breathe life into lifeless worlds? To understand terraforming, we must first consider the conditions necessary for human survival. Earth is uniquely suited for life, with its breathable atmosphere, moderate temperatures, and abundant water. Any attempt to terraform another planet must replicate these essential elements. Let's take a closer look at Mars, our closest planetary neighbor, and one of the most promising candidates for terraforming. Mars is often referred to as the red planet because of its iron oxide-rich soil, which gives it a rusty appearance. With a day similar to Earth's and a landscape filled with mountains, valleys, and polar ice caps, it seems like a fitting candidate for transformation. But what are the challenges? First and foremost, Mars has a thin atmosphere composed mostly of carbon dioxide, with very little oxygen. This means that any effort to make Mars habitable would involve thickening its atmosphere and increasing its temperature. Scientists propose several methods to achieve this. One idea is to release greenhouse gases, such as carbon dioxide, to trap heat and warm the planet. Another exciting possibility is to introduce genetically modified organisms that could survive in harsh Martian conditions. These organisms could produce oxygen and help create a more suitable atmosphere over time. Imagine tiny bacteria or specially engineered plants flourishing on the Martian surface, slowly transforming the environment as they grow. Then there's the question of water. Mars has water ice in its polar regions and beneath its surface, but liquid water is scarce. To support life, we would need to melt this ice, creating rivers and lakes. This could be achieved by increasing the planet's temperature through the greenhouse gas method or by using giant mirrors in space to reflect sunlight onto the Martian surface. Yet, while Mars presents an exciting opportunity, it's not without its challenges. Cosmic radiation is a significant hazard for any potential colonists. Without a magnetic field to protect it, Mars is bombarded by solar and cosmic radiation, which could pose severe health risks. Any successful terraforming project would need to address this issue, perhaps by constructing protective domes or underground habitats. As we ponder the possibilities, we must also consider the ethical implications of terraforming. Is it right to alter another planet's ecosystem, potentially destroying any native life forms that may exist? These questions challenge us to think deeply about our responsibilities as stewards of the universe. Now let's turn our attention to Venus, often called Earth's twin due to its similar size and proximity. However, the conditions on Venus are extreme, with crushing atmospheric pressure, scorching temperatures, and clouds of sulfuric acid. At first glance, it may seem like an impossible task to make Venus habitable. However, some scientists believe that terraforming Venus could be more feasible than we think. One proposed method is to float cities in the planet's upper atmosphere, where the temperature and pressure are more Earth-like. These floating habitats could harness solar energy and create a more suitable environment for human life. Even if the surface remains inhospitable, the skies of Venus might one day host thriving colonies. But how do we begin transforming an atmosphere that is 96% carbon dioxide? One approach is to introduce microorganisms capable of photosynthesis, which could convert carbon dioxide into oxygen. Over time, these organisms could help to reduce the greenhouse effect and create a more breathable atmosphere. In both Mars and Venus, The concept of terraforming pushes the boundaries of our understanding of biology and technology. Scientists are exploring innovative techniques to manipulate these alien environments, and while the challenges are immense, the potential rewards are equally significant. As we explore these possibilities, we must also consider the role of technology in making terraforming a reality. Advances in robotics, genetic engineering, and space travel will be crucial in our quest to reshape other planets. Imagine autonomous drones planting trees on Mars or robots mining resources to build habitats. Each technological leap brings us closer to the dream of interplanetary colonization. The timeline for terraforming is another aspect worth discussing. Some scientists estimate that it could take hundreds or even thousands of years to make Mars or Venus habitable. This long-term commitment requires careful planning and sustained investment. We must ask ourselves, are we ready to embark on such a monumental journey? Furthermore, we must also consider the implications of terraforming on Earth. As we look to the stars, we must ensure that we do not neglect our own planet. Environmental challenges like climate change and habitat destruction demand our immediate attention. Terraforming other worlds should not distract us from the stewardship of our own home. One of the most compelling arguments for terraforming is the potential for human survival. As our population grows and resources become scarcer, the ability to colonize other planets could provide a vital lifeline for humanity. Terraforming could serve as a backup plan, ensuring that our species can thrive even in the face of global catastrophe. However, we must tread carefully. The desire to create new worlds must be balanced with humility and respect for the cosmos. We have a responsibility to explore and expand our horizons while recognizing the beauty and complexity of the universe as it exists today. As we continue to unravel the mysteries of terraforming and its potential, we cannot help but feel a sense of wonder. The very idea that we could transform distant worlds into habitable paradise evokes a thrill of possibility. What if the future holds not just one home for humanity, but many? The science behind terraforming is still in its infancy, but the exploration of this concept inspires us to dream big. Each advancement in our understanding of planetary science brings us closer to the day when we could walk on the surface of Mars, breathe its air, and plant our flag among the stars. So, as we look to the future, let us keep our curiosity alive. The quest for knowledge and understanding has always been a driving force for humanity. Who knows what discoveries await us as we venture further into the universe? The mysteries of terraforming are just the beginning of our journey. In conclusion, the science behind terraforming other planets raises profound questions about our place in the universe. It challenges us to imagine a future where humanity can thrive beyond Earth, transforming barren worlds into lush havens. As we stand on the brink of this new frontier, we must navigate the challenges and ethical implications that arise. The journey is long and the obstacles are formidable, but the potential rewards are worth the effort. Together, let's explore the possibilities of shaping new worlds, and in doing so, discover more about ourselves and our responsibility to the cosmos. What happens next in our quest to uncover the mysteries of space? Stay tuned for more. Don't miss out, subscribe now.